guys, welcome to TNTVKT, and today we'll be talking about electricity and current. So starting with some formulas. Q is equals to IT. This is the basic formula of current. Charge is equals to current into time. So current is charge per unit time. Then the other formula is I is equals to VENA, which means I, current, is equals to drift velocity. E means electron, or we can write Q also in if we have to put the value of charge. N means number of electrons, so Ne. Then finally A means, well, A means cross section area of conductor. Cross section area of conductor. Sorry, here E means charge, that is 1.6 into 10 to the power minus 19. And then N means number of electrons per unit volume in a cross section area. This is a conductor, and number of electrons per unit volume means N, number of electrons per unit volume. Similarly, the third formula is of drift velocity, which is V is equals to E by 2m into T. E means charge of electron. E means this is electric field apply, and M means mass of electron, and then this tau means time of relaxation. We know that electrons collide with each other, then the time that has remained after that has passed after the recent collision is tau. So we do not need it in the depth. These are the three formulas. Now we will start with laws. First, Ohm's law. This means V is directly proportional to I. V is equals to IR. Well, you can derive other formulas from this. V is equals to IR. So we know that P is equals to VI. So we can write P is equals to V square by R, or P is equals to I square into R. These are mostly asked in various short questions in objective, problems. Now then we will Kirchhoff's law. Well, Kirchhoff's first law is conservation of charge, based on conservation of charge, and second law is based on conservation of energy. Well, first law, conservation of charge, states that when in a junction the input current is equals to output current, this much, and Kirchhoff's second law states that the algebraic sum of voltage or current into resistance, algebraic sum of voltage or algebraic sum of current into resistance is equal to the algebraic sum of EMF taken in a closed loop. Well, there are sign conventions and lots of stuff you can learn yourself. So now we will be going on. So now, effect of temperature and metal and semiconductor. So when temperature increases, metal resistance increases, but when temperature increases, semiconductor resistance decreases. So now let's discuss on two bulb problems. Well, you can look clearly here. The first bulb is labeled 220 volt 100 watt power, then the second one is 220 volt 50 watt power, and the supplied voltage is 440 volt. So in order to find which bulb will glow and which bulb will fuse, we have to find the resistance of each bulb and then total resistance in the first step. So finding resistance, P is equals to V square by R. So R will be first V square by P. So R will be V square by P. Then in the first case 220, then R1 is equals to 220 into 220 by power is 100, and it will be 22 into 22. And then resistance of second one is 220 into 220 by 50. So we have to calculate 22 into 22, 4 cross 4 will 484. Now then, to make it 10, we have to multiply upside and downside by 2. So this will also cancel this, and then it is double of how much we get. It is the double. So 488 into 2, 4 to the 8, 8 to the 16, 6 1 carry, 4 to the 819, 962, 968, 4 to the. So the resistance of the first bulb is 484 and the other is 968. So now the total resistance is 484 plus 968, 6, 8, 19, 11, 12, 13, 14, 1, 15, 5, 1. So if you add the two resistance as they are in series, it will come about 1452. And then now finding voltage obtained by first bulb. Voltage by first bulb is equals to 484 by 1452 into supplied is 440 volt. So it seems a bit big, but let's start. 2 to the 4, 2 4 the 8, 2 to the 4, 2 7 the 14, 2 to the 4, 2 1 the 2, 2 7 the 14, 2 to the 4 1, 2 6 the 12, sorry, 2 1 the 2, 2 to the 4, 2 1 the 2, 2 3 the 6, 2 6 the 12, 2 3 the 6. Now it seems with 3 and 3 3 to the 6, 3 1 the 3. So here is also root 1 to 1, here is also 1 to 1. So let's make it if we divide by 3 it will come out. So let's make it divide by 3 to compensate. Here we will dividing by 3, and now here we will multiply by 3. So 1 to 1 cancel. 440 divided by 3, 440 divided by 3, 3 1 the 3, minus 1, 14, 3 4 the 12, minus 2, 20, 3 6 the 18. So it will go on, but it will come out 146 volt. If you calculate in calculator, it will come about 484 into 440 divided by 1452. It will come 146 only, 146.6. So it will let's take 146. So now voltage by first bulb is 146 volt, and then voltage by second bulb is voltage by second bulb means 440 total voltage supply minus 146, it will be 4 440 minus 146, it will be 294 volt. So second ball will be 294 volt. So now we have calculated second ball fuse when B supplied is greater than B labeled. B supplied is 146 and the level is 220 volt, so it will glow, but 294 volt and labeled is 220 and the supplied is 294, so this bulb will fuse. And then resistance of filament with greater power is small. That means which one add greater resistance? The first add resistance 484 and second 968. So this add greater resistance. Then the power will be small. Yes, 50 watt. Power will be small when the resistance is 968. Resistance is 484. So high resistance, low power. In series, bulb with lower power glows more. In series, bulb with low power glows more. If it was to glow, then this will glow brighter than this. But here in this condition, it was fused because supplied is greater than labeled. In series, bulb with low power glows more. So and then filament of 50 watt bulb is smaller than 100 watt. Filament of 50 watt bulb is smaller than 100 watt. So the more watt, thicker filament. So I have given the relation like this: power high, resistance low. Bulb with power high have low resistance, low brightness, but the filament is maximum. So filament is thick. Power high, low resistance, low brightness, big filament, thick filament. So let's discuss on Wheatstone bridge problems. Well, galvanometer is connected between this and this. Let's take A and this point as B. A and B galvanometer connected, and let's take C and D. Battery is connected between C and D. So when we interchange galvanometer position and battery position, there will be effect in Wheatstone bridge? No, because there won't be any change in Wheatstone bridge, which is one of the important problems. So the convention current will go from positive to negative. So let's discuss on this. Here are two resistances resistance on upper part PQ, 6 ohm, 12 ohm, then XR, 12 ohm, 6 ohm. So from which side will current pass, A to B or B to A? Well, for this you have to check P in crisscross, P into R relation, Q into X. So P is 6 into 6, 12 into 12. Which one is greater? Obviously this one is greater. If this and this multiply is less, then this and Q, X and Q multiplied, then current will go from B to A. So current will go from B to A, because multiplying this P and R is less. PR less, down to up, PRI up to down. This is the you can find the direction of current like this. So now let's discuss one question related to finding required resistance between 2 points. So here same resistance in the diagonal, and two resistance are different, 10 ohm and 10 ohm. So to find this, you have to first multiply all these. You have to make like a summation. Then you have to multiply all, and then you have to divide the vertical ones, adding the vertical ones. So I'll show you how. 10 plus 5, 50. 5 plus 5, it will be 25. Plus, then 5 plus 10, 50. Then 10 plus 5, 50. divided by, so vertical ones, 5 plus 5 10, 5 plus 10 15, so 10 plus 15. This is the required answer. It will come 7 ohm. In this way you can easily find whose diagonals are of same resistance. So summation sign you have to make like a summation sign like this, and then you can solve problems easily. There is another problem here. This looks like a mess, but it's quite easier compared to others. You can see here are 3 resistance, here are 3 resistance, and there is 1 resistance. So if you draw a vertical line like this, it will be symmetrical. This half part will be equal to this half part. So in this condition we can remove this point from the joint. So it will be R R R R R R R. So this point can be removed like this. Now you can solve them. These two are in series and then in parallel, and then you can find the other. Then you can easily solve these questions. I think I should not tell you about this, but let me tell you. If the resistance are in series, then the resistance R required will be R1 plus R2 plus R3. And then if they are in parallel, it will be 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Well, if there are only 2 resistances, then R equivalent is equals to R1 R2 by R1 plus R2. This is nothing but just a shortcut in finding required resistances. Now let's discuss combination problems. So the number of combination from n resistors and number of resistors of equal value, it will be number of combinations 2 to the power n minus 1. Number of combinations if equal value, if the resistance is equal value, and if they are of different value, then 2 to the power n. This you must learn. And then let's start finding EMF and total resistance. Well, here is a series. If this is 1E, 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 and there are different E's, then the number of EMF, total EMF, it will be E1 plus E2 plus E3. Well, the well, the EMFs are all same, so NE, total EMF. Now when there is one combination like this, EMF 3, and then finally one is mistakenly changed. Now this is E. Now what will be the required EMF? Well, the required EMF will be this plus, so 3E. We cannot add this, but it will get subtracted, so minus 1E. Well, in question you are given total EMF is before it was changed, it is 1 2 3 4, then it will be 4. Now then, if 1 is altered, well, now this was the previous condition. Now the cell is altered, final one cell is altered, then now total EMF will be if this question is not given, then you can write 4E minus 2E, because 1 2 3 added and 1 subtracted. Why this is minus 2e, because one, like this, one EMF will not be added, and rather it will be subtracted, so it will be minus 2e. So the required answer is 2e. This is the important problems. This comes under important problems. So now talking about total resistances. As I had discussed earlier, R series is equals to R1 plus R2 plus R3 dot dot dot, and R parallel is equals to 1 by R parallel is equals to 1 by R1 plus 1 by R2 plus dot 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 dot. So now let's discuss combination of cells. Cell are in series. So now required current through them will be, well, the formula for current is I is equals to total EMF by total resistance. Well, the total EMF in this case will be 1 2 3 dot dot dot, so it will be any, like this I discussed earlier. And then the resistance will be R. It will have internal resistance R, so internal resistance will be NR. Wait, not only internal resistance, but there will be external resistance too. External resistance will be R. So now total resistance will be NR plus R, because it is in series. So this is the required relation for current in series. Cell in series, then I is equals to NE by cell in series, then NE by NR plus R. Now let's discuss cell in parallel. If cells are in parallel, then EMF will be same. So total EMF is equals to E, only E. And the total resistance will be, well, we have to calculate the total resistance. 1 by R equivalent is equals to 1 by R1 plus 1 by R2 dot 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 dot, dot N. So it will be 1 by R equivalent is equals to N by R, because all are same. So now R equivalent will be R by N. This is for internal resistance R of the battery. Internal resistance R, so R is required. R required will be R by N. And then wait, there is one external resistance too. So now if there is one external resistance, it is in series with this combination, so plus R. This is the required relation, cell in parallel. It seems a bit messy, but you can understand. It's only a revision. So now these two combinations will be combined in one. Now what will be the relation here? Well, you can look here 1 2 3 dot 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 N are connected in series, and 1 2 3 dot 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 M are connected in parallel. Now here are M and N, number of rows M, number of cells in each row N. So now to find the required current, I is equals to total EMF by total resistance. So well, I had forgotten one thing. I think here will be external resistance too. External resistance will be in series with this combination. Well, first we have to find EMF. EMF E N. So it will be EMF will be same in parallel, but it will be added in series. So from this it will be any, from this also it will be any, from this all it will be any, but there it won't be added and it will be same, so EMF will be any. And then for resistance, every cell will have internal resistance. First, series will have an R, because I discussed earlier, total resistance will be added 1 2 3 4 n times nr. So nr, and then to find 1 by R equivalent is equals to 1 by nr plus 1 by nr plus dot 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 dot, it will go up to m times. So it will be 1 by R equivalent is equals to m by nr. So now the required R equivalent is equals to nr by m. So now R equivalent means nr by m. Sorry, nr by m. M means number of rows, plus now external resistance R, as these two combination are in series. So this is the required relation to find current in this mixed combination. Now there is other type of problem where a resistance wire is cut and joint. Firstly, the resistance wire had resistance R. Now it is cut. Let's cut it into 4 parts. 3, 4. So if one resistance is cut into 4 parts, it will be R by 4, R by 4, R by 4 and R by 4. So now if we will join, then it will be same R, because R by 4 plus R by 4 plus R by 4 plus R by 4 will be 4R by 4, that is R. So R series, if we join it in series, it will be R same. And but if we connect it in parallel, then it will be 1 by R equivalent is equals to 4 by R plus 4 by R plus 4 by R plus 4 by R. 1 by R equivalent is equals to 1 2 3 4 4 into 4 by R. R equivalent is equals to R by 16. Well, you don't have to do this long, because there is one shortcut. For R series, you have to write whatever it was initially, and for R parallel, write 1 resistance and then square the lower one, it's equals to R by 16. This is the shortcut. And then now when the resistance is bent and joint, firstly the resistance was R. Now this resistance was bent in the form of circle and joined. Now you can take from here, from here, from here, from here. Now the resistance will be, well, there is one process. Well, something it is given angle, for example 30 degree, this and this all total is resistance, and now here is point A and point B. So now if we look at it clearly, it will be, and so A and B, and now this resistance and this resistance, upper resistance and lower resistance, sorry, B here, upper resistance, lower resistance. So it will look like a parallel. First we have to find the this portion resistance, 30 by 360 into total resistance is 30 by 360 into 3 1 the 3 3 2 the 6, so it will be R by 12. Lower portion is R by 12 and upper portion will be R minus R by 12, so it will be 11 R by 12. So now as they are in parallel, now we have to find the required answer R is equals to multiplying 2 and R by 12 into R by 2 by adding 12, 11 R by 12 plus R by 12. So if you multiply, it will be 11 R square by 12 into 12. 11 square into 12 into 12 by 12 common, so 11 R plus R by 12. So it will be 11 R square by 12 into 12 into, if you take up, 12 by 12 R, so 12 cancel, R cancel, it will be 11 R by 12 square. Well, this is the process, but I'll give you a formula and it will be easy. So you get 11 R by 2. First you find this as R by 12 and 11 R by 12. So the required answer is square of downside. 11 R by 12 square of downside. So if it is, here it is 11 R by 12 this part and it is R by 12, then the required answer on this other part square to 11 R by 12 square is the answer. Then the finally is stretch. There is nothing more complex in stretch because it is very easy. Resistance is directly proportional to length square L square, and then it has, and R is inversely proportional to area square. From this we can derive more. R is directly proportional to 1 by diameter square, diameter to the power 4. Then R is directly proportional 1 by radius to the power 4. These are the 4 relations that you must remember to find out stretch problems, bend and joint problems, cut and joint problems. So let's continue with resistivity. Resistivity is the reciprocal of conductivity. R is equals to rho L by A. This is length of resistance, area of cross section, and this is rho means resistivity. Now when resistivity are connected in parallel, it will be rho 1 rho 2 by rho 1 plus rho 2. It will be same like resistance, but when it is connected in series, it will be rho 1 plus rho 2 by 2. This is quite different, divided by 2. Now it developed is equals to current square resistance into time in a conductor, in a resistance. In a resistance, it developed is equals to I square RT. In series, power is reciprocal addition, time is addition. With increase in time increases if resistance are connected in series, and then H by T, reciprocal of heating mass by time, is in reciprocal proportion like this. Reciprocal addition in series. This is in a series case, which is opposite in case of parallel. If a cell generates same heat in a external resistance R1 and R2 by supplying current for time T, same current, same time, same heat, current, time means same, then the internal resistance will be root under R1 into R2. It will be R1 into R2. So now here R is equals to R0 1 plus alpha delta theta. This is one of the most popular relation. Then terminal PD during discharging. Terminal PD during discharging will be V is equals to E minus IR. So E will be, when it is discharging, E will be large. When it is charging, V will be large, so V is equals to E plus IR. When it is discharging, E will be high, EMF will be high. When it is charging, potential difference will be high. E is equals to V minus IR in discharging case, V is equals to E plus IR in charging case. Now Faraday's law. Faraday's first law means M is equals to ZIT. Z is equals to equivalent weight of that metal by Faraday constant 96500. Faraday constant. I current, T means time. Time solar mass deposited. This is in two resistors connected, and then mass deposited will be Z means E equivalent weight by Faraday constant, I current, T time. Second law means M1 by M2 is equals to equivalent weight 1 by equivalent weight 2. So mass deposited of one equivalent weight is directly proportional to equivalent weight, means M1 by M2 is equals to E1 by E2. Now Wheatstone principle. We know a Wheatstone bridge. Let's draw one. There is one galvanometer and it is connected to battery. P, Q, X, R. What is Wheatstone principle? Wheatstone principle is P by Q is equals to X by R. This is the Wheatstone principle. P by Q is equals to X by R. So now this is what? What is this? This is a meter bridge. Meter bridge. The total length is 1 meter. If this is L, it will be 1 minus L meter. L meter 1 minus L meter. So if we take it as resistances in this, it will be P by Q is equals to X by R. Well, X is this will be 1 meter. Sorry, this will be 1 meter. And if this is L, it will be 1 minus L. So X is L, R is 1 minus L or 100 minus L if it is in centimeter. So this is the relation for meter bridge. So finally let's discuss on this. What is this figure? This is a potentiometer. Battery, you start connected to a resistance. It is also connected. It's the same thing. And then to find out resistance, firstly the key is not open. In this key is open, and then it will get one EMF, and when key is closed, it will get voltage. So the formula is R is equals to E by V minus 1 into R. R is this resistance. Now another formula for E is L1, L2. So when it was E, L1 will come, and when it was V, L2 will come, and the formula is L1 minus L2 by L2 into R. These two are the formulas to calculate a resistance of cell. Resistance of a cell. So now comparing EMF of two cells, E1, E2. When it is one connected, one EMF will come, and when it is connected with this, another EMF will come, and their L1 and L2 will come in different cases. Well, in first case L1 when it is connected with this, and second case when it is L2 will come. So it will be E1 by E2 is equals to L1 by L2. In this way we can find EMF of cell by using potentiometer, resistance of cell by using potentiometer. So now let's discuss on resistance across two bases. Well, you have to remember FDS 357. This means phase diagonal. Phase diagonal is equals to 3/4. Diagonal is equals to 5/6. Border side diagonal is equals to 7/12. And then finally vacant side is equals to 7/5. Well, this one is our resistance. So phase diagonal means this and this of one phase. Diagonal means this and this. Side diagonal, and then vacant side if one side is vacant, and then across this. So you have to just remember the values, and it rarely comes in exam, but you must understand to solve in exams. Now we will be discussing on ammeter. Ammeter means small resistance connected to parallel. This is a structure of ammeter. This one is galvanometer, this one is resistance. So when I current passes through here, Ig current passes through this, and I minus Ig passes through the resistance S. Let's suppose, so when this and this are in parallel, then the voltage will be equal. Ig into G is equals to I minus Ig into S. This is the required expression of ammeter. So now voltmeter. Well, voltmeter means connecting high resistance in a series. Suppose current I is passing through galvanometer, then I current will pass through resistance R. So in this case, the total voltage of a voltmeter is V is equals to IgG, because Ig current, the current passing through galvanometer is Ig, so this will also be Ig when I current enters into the voltmeter. Ig plus IgR. This is the required expression for voltmeter. This is the required expression for voltmeter. Now talking about current sensitivity. Current sensitivity, theta by I is equals to NAB by C. Voltage sensitivity is equals to theta by V, means NAB by CR. Values will be given in question, and just you have to solve using the formula. And then we will now discuss on thermocouple. So now let's discuss on thermocouple. Let's take two metal wires, stibnum and bismuth, and here is cold junction and here is hot junction. Now there are two views on this. One is Seebeck effect and another is tail shear effect. According to Seebeck effect, when two metals are connected and there are two junctions, hot and cold, then current will flow from antimony to bismuth in cold junction. Current will flow from antimony to bismuth in cold junction, and which is just opposite in case of hot junction, bismuth to antimony in hot junction. Similarly, in case of iron and copper, current will flow from iron to copper in cold junction and copper to iron in hot junction. This is Seebeck effect. Then in Peltier effect, Peltier effect, when there is a junction of two metals and then current is passed through them. That means current is flowing from year to year. Then hot and cold junction will be developed, like here, going from antimony to bismuth here. So it will be cold junction and it will be hot junction. So our temperature, cold and hot junction will be developed, which is Peltier effect. And the other one is Thomson effect. When current is passed through a thermocouple, heat energy is either absorbed or evolved along the length. This one is Thomson effect. Well, let me just tell you, these are reversible, but Joule's effect is irreversible. Seebeck effect is used as thermoelectric generator, and Peltier effect is used as thermogenetic refrigerator. Thermoelectric refrigerator. Here is one figure across thermo EMF and temperature of the junction. Well, from start it is theta naught, and then it rises up, and finally it goes to 0 and then goes on negative. So this maximum point is theta n, and this is theta I. Theta 0 is, it starts with 0 degree centigrade. So here is one extra, theta naught means temperature of cold junction. Theta n means neutral temperature. And then theta I means temperature of inversion. So the formula is theta n is equals to theta naught plus theta I by 2. So this is neutral temperature, and rate of change of thermo EMF with temperature increase. Temperature difference of hot and cold junction of thermocouple is thermal power. And this thermal power is 0 is in neutral temperature because E is maximum. then it will be 0. This is thermal power, rate of change of uh, EMF with temperature difference of hot and cold junction. This was for today. Keep tuned for more videos.